So, seismic waves, this is what you feel. Who has felt a large earthquake? By large, I mean more than a 5. A few? Are you all too young for Northridge now? Were you born in 1994? Only just, and most of you, oh my goodness, you're so young. Okay, so that was the last big earthquake in the LA area, and it did a lot of damage, and it killed people, unfortunately. And really what sort of is damaging is this energy that is being released and sent out in the form of seismic waves. That's what causes the shaking that we experience. And for those of you that have felt large earthquakes, and even smaller ones locally, you get a little rumbling first, right? You get a little bit of a rumbling, and then perhaps it gets a little bit more significant. And then usually after that, there's another big jolt. Everything doesn't arrive in one go. You can actually feel this. And next time there's an earthquake, I want you to think, apart from, let's get under a table, see if you can identify those different arrival times of the different waves. Okay. So we have 2 families of seismic waves. We have things called body waves, which will travel outwards in all directions, so they will go through the earth. We also have surface waves, and they will only go along the surface, which is nice and easy to remember. Okay, and these can be recorded by seismometers, and you can imagine how as you get shaking in the vertical direction, that moves the spring up and down, and so that leaves a mark on that sort of rotating roll of paper. And then the same idea with the pendulum is that as the ground moves under that pendulum, the pendulum stays in the same place, and so we'll draw sort of horizontal lines marking the horizontal motion. And so we get something that looks a bit like this. We get what we call the P waves arriving first, then we have S waves, and those are 2 types of body waves. Those are the ones that travel outwards in all directions, including through the earth. Then we have our surface waves. And our surface waves, you can see from the size of them, are usually the more damaging part of the earthquake. Those little rumblings you feel first are the P waves and the S waves, and then the real jolt is from those surface waves. So let's look at P waves and S waves. And I need a volunteer who signed our video waiver form. Do I have a volunteer? It's nothing too onerous, I promise. No? No volunteers? Come along, come to the front. Excellent. One brave soul. It's not too challenging, I promise. Okay. All I want you to do, yes, round of applause. Okay, is hold that there, and hold it on the ground. Okay, so I'm going to demonstrate to you the difference between P waves and S waves. So P waves are compressional waves. We're sort of compressing something. And so P waves travel like that. Okay? They compress in the direction that they're moving. If we talk about S waves, I like to think of these as shear waves, or you can think of them as shape waves. This is what happens in shear waves. Okay? So P waves travel the same direction, S waves travel side to side, okay? And this is why P waves will travel straight through the earth, even through liquid. S waves won't, okay? Thank you very much, that's all. Great, thanks. So P waves are these compression waves, and they travel just like sound waves. So if you're sat at the bottom of a pool holding your breath, because why wouldn't you? You can still hear sound from above, right? That sound is coming down through the water, it's moving down. If someone sticks their hand in the top of a swimming pool when you're at the bottom and waggles their hand backwards and forwards, you're not going to feel movement associated with that, okay? So those are the different types of waves, and that's why some will travel through the earth and some won't. And those P waves, the ones that arrive first, travel the fastest, makes sense. They travel at about 13,000 miles per hour. And those S waves travel probably only about half as fast, maybe 7,000 miles per hour. Okay? And then we have our surface waves, which are even slower because they have to come around the surface as well. And there's 2 types. There's love waves and rally waves. I don't want you to worry about those names. But you can see again there's different senses of motion associated with those. Love waves are backwards and forwards, and Rayleigh waves are sort of circular, and these are the damaging waves. Okay. So these seismic waves can actually tell us a lot of information. There are three things that we can learn from seismic waves. First of all, the location of the epicenter. So we can use the arrival times of these waves to work back and think about how far away we are, and therefore where the center of the earthquake must have been. We can get an earthquake strength from these waves and our record of them. And we also get information about the Earth's interior. So first of all, I want you to look at our little seismic trace at the top. And you can see that the P waves arrive at a certain point, and then the S waves arrive. And the problem you have, if you're just at some seismic station, you go, earthquake, and you look at your seismograph and you see the P waves and then the S waves, is that you don't necessarily know when they started. Because you all know, because you all drive a car, that you can use the distance and the time and things to get at speed. And we know the speed of these waves, and we know how we have a sense of the time. We want to know the distance. Okay? But we don't know the exact time when the earthquake occurred. So we can't directly use that idea. What we instead have to use is the difference between the P wave arrivals and the S wave arrivals. Because we know how quickly both of those travel. So if we know the time difference between those, we can get back to distance. So, and this is what my graph shows here. You can see that the lower line shows P waves, showing distance in kilometers from the focus along the x-axis versus time. So in our example here, at 4,000 kilometers distance from the epicenter or the focus, then it takes our P waves 7.4 minutes to arrive. And it takes our S waves, the upper line there, 13.7 minutes to arrive. Okay? What we can't measure, we don't know the 7.4 minutes or the 13.7 because we don't know when the starting point was. But what we can measure is the difference between those. So we know that there's a difference between those values of maybe, 6.3 minutes. So we can look at the time difference between those two lines, and where it lines up with 6.3 minutes, we know that that is the distance from the focus or the epicenter. And I'm going to give you a chance to do this now. So hopefully you followed that. So if the time difference between the P waves arriving and the S waves arriving is 10 minutes, how far away is the epicenter of that earthquake? So talk to your neighbors for a couple of minutes, see if you can work out roughly where it is, and then I'll open up the vote. Okay, so I'll start the vote. If you have an idea already, vote, but I'll give you a couple of minutes if you still want time to think. The TAs are scattered around, you can ask them as well. Okay, I think we've got most votes, so if you haven't had a chance to put your answer, give you a couple more seconds. Okay, so let's see if we have an idea or if everyone's completely and utterly lost. Ooh, 50%. I think that's the best I've ever got on this question. Good work. Okay, so C is the right answer, and I'm going to tell you why. So remember, I mean, it's actually a difficult graph to read. I do understand that. Okay, so the time we have is the difference between the P waves and the S waves. So if we look, we want this difference between these two lines to be about 10 minutes. So if we look at maybe 5 kilometers, then the P waves arrive maybe at 8 minutes, and the S waves arrive maybe at 16 minutes. We've only got an 8-minute difference. So that's obviously too close. If we look at 12 kilometers, our P waves maybe arrive at 15, our S waves maybe arrive at 28. We've got too much of a time difference. There's like 13 minutes there. If we look at 8 kilometers, our P waves arrive at maybe sort of 10, 11. Our S waves arrive at maybe 20, 21. So there's a 10-minute difference. And then we can look at that, wherever that distance is, and we can look down and say it must be 8 kilometers away. Okay? And we'll have a chance